Okay, in this recording we're going to start talking about series circuit and parallel circuits. A complex circuit is a circuit with more than one resistor, and the easiest way to hook them up is either in series or parallel. We'll do more complicated ones later. The definition of a series circuit: in a series of movies, they come out one after the other. They don't come out all at the same time, right? There is Star Wars 1, then Star Wars 2, then Star Wars 3. And it's in the same way, in series, the electrons flow through one resistor, then second resistor, and so on. And they have to flow through all of the resistors. Now, it may make more sense to see a picture of it. Here's my battery, and I might have a resistor here. Call that R1. Resistor here, R2. Resistor here, R3. And that's going to give me, battery's going to be my voltage. Now, the rules for these, we can just get from the loop rule and the junction rule. By the junction rule, if I look at any junction, say that one right there, the current into that junction has to equal the current out. So whatever comes out of the first resistor has to go into the second resistor. They're going to be the same. And then whatever comes out of the second resistor to this point has to go into the third resistor. So the currents there are going to be the same. And then that all has to go into the battery. It comes back out of the battery. So the current is always the same. So we can write that as I total equals I1 equals I2, and so on. Now, if I think of the loop rule for the voltages, whatever voltage I gain in the battery, I lose by the time I get back. So I can write here my V total from the power supply. I gain V total there, then I'm going to lose some of it through R1, I'm going to lose some of it through R2, I'm going to lose the rest of it through R3. So it's going to equal V1 plus V2 plus V3. All right, and then our resistances also add up. The electrons have to fight their way through all three resistors. That's going to be harder than just one by itself. So the total resistance is equal to the sum of the individual resistances. Now, when we have one of these problems, we're going to have to find the voltage, the current, the power, in every part of the circuit. Now, I tend to use a chart to make my life a little bit easier, helps me keep track of things. So I put total 1 and 2 across the top, and then VIRP down the side. Now, my voltage is 30 volts for my total, so I'm going to put 30 volts total in there. Then my first resistor has resistance of 5, and my second resistance is 10. When I go horizontally in this chart, I'm going to use these rules up here, okay? And when I go vertically in the chart, I'm going to use V equals IR and P equals VI. So I need to have 2 in either a column or a row. So I have both R's here, so I can fill out the R total. So I'm going to use this R rule. R total is R1 plus R2 plus R3. It's just a sum. So this R total is going to be 15 there. Now I have 2 in that first column, so I can use V equals IR. V equals IR, and that gives me 30. It is I times 15, so I equals 2. Then we put a current of 2 in there. Now, I'm a little bit stuck, but I can look at my V rules and my I rules. Oh, the I rule says I total equals I1 equals I2. They're all the same. So I'm just going to fill in 2 here and 2 here. Now, vertically, I can do V equals IR again. So I times R. 2 times 5 equals 10. 2 times 10 equals 20. My check is my V should add up. V total is V1 plus V2, da-da-da. So V1 is 10 plus V2 is 20. That's equal 30, so that works. Then for my powers, I'm going to use P equals VI. So for the total, it's going to be P equals 30 times 2 is 60. So I'll put 60 down here. And then P equals V times I, so 10 times 2 is 20. 20 times 2 is 40. There's another check. The powers are going to always add. Whatever power the battery is given me is being used up by the 2 resistors. Another example. Voltmeter reads 212 volts, so I'm going to write here that V is 12. Now we're going to call that one V1 because as I go around the circuit, that's the first resistor I get to. And then again, I want to find all of the values for the circuit. So V, I, R, and P, total 1 and 2. So what I was given this time is that the total voltage is 60. I have V1 is 12. And I have that this second resistor has a resistance of 10 ohms. And now I got to try and fill this thing out. Well, I can go horizontally through the circuit, or on the chart. So my V rule was that the V's add up. So 12 plus something equals 60. So this one has to be 48. Okay, now vertically I can do V equals IR. So 48 is I times 10. So that gives me I is 4.8. Okay, now our current rule, the I rule, says that up here all the currents are the same. So I have 4.8 here, and I have 4.8 there. Now I can use V equals IR again to get the R's. So V equals IR, so 4.8 times R equals 60. So if I do 60 divided by 4.8, I will get my value. And that's going to give me 12.5. Here I'll do 12 divided by 4.8. And that gives me 2.5. Now for a check, the resistances should add to the series circuit, and they do. 2.5 plus 10 equals 12. Now for my powers, I'm going to multiply the V and the I because P equals V times I. So 60 times 4.8 is 288. 12 times 4.8 is 57.6. And then 48 times 4.8 is 230.4. And those two should add to the total, and they do. Now we're going to move on to parallel circuits. Parallel circuits, the electrons choose one of the resistors to go through. So they don't go through both. So like this, and there is a parallel circuit. So the electrons, you have to draw this part, the electrons maybe are coming out of the negative side of this. When they get to this point, they're going to choose. Some of them are going to go this way, some of them are going to go this way. So I'm going to label this R1, R2, this over here V. This is my total current that's coming out of the battery. And then it's going to split into I2, the current going through the second resistor, and I1. So our rules, again, we use the loop rule and the junction rule. Okay, we'll do the junction rule first. If I look at this junction, I have I total coming in, then it splits. I1 goes through the first resistor and I2 goes through the second resistor. So the total in equals the total out. So I total coming in has to equal I1 plus I2 plus, and if there are more resistors, I would add to that. The voltages we'll do loops for. So let's just look at the left loop. As I go around the left loop, I gain voltage V in the battery. And then I lose it all when I go through R1. If I'm going in the left loop, I only go through R1. So V total equals V1. Now if I do the outside loop, whatever I gain in the battery, I'm only going through R2, so I lose all of it in R2. So V total has to equal R2. So that's going to equal, V total has to equal V2. And it turns out that all the voltages are going to be the same. So the rules kind of flip-flop. In series, the voltages add and the I's were the same. In parallel, the I's add and the voltages are the same. The resistor rule is a little more complicated. It's 1 over R total equals 1 over R1 plus 1 over R2, and so on. So we will do that in a moment. Now, For this example, it says find the equivalent resistance, then find current potential difference in power for each element. So I'm going to write VIRP total 1 and 2. Okay, and let's see, we have a total voltage of 30. R1 is 5, and R2 is 10. Now, if this was series, we would simply add the 5 to the 10, but it's not. It's parallel. The rule is a little more complicated. It's 1 over R total is 1 over 5 plus 1 over 10. The common denominator would be 10, so that equals 2 tenths plus 10 is 3 tenths. Now, we're not done. That's not our answer. That's 1 over our total. So our total is going to equal 10/3. We have the reciprocal there. And that ends up being 3.3 repeating. So we'll put that in here. So it's kind of funny, the total resistance actually ends up being less than either R1 or R2, and that will always happen. The way I think of that is, it's like cars driving on a highway. I think of each of these as a lane on the highway, right? So all of the current gets to this point, and then some go in one lane, some go in another lane. If I open up a third lane, the traffic's going to speed up. Okay? Speeding up traffic means there is less resistance. Now I'm going to start using my rules, so I can use V equals IR. So I get 30 is I times 3.3 repeating, and I'm going to end up with I equals 9. Now, what am I going to do next? Well, I'm going to look at the V rule. The V's are all the same. So I'm going to put 30 in here and 30 in here. Now, for my I's, V equals IR, so I times 5 here, I times 5 equals 30. So this current has to be 6. And then what times 10 equals 30? That has to be 3. My check, in parallel, the I's have to add, and they do. 3 plus 6 does equal 9. And then I'll use P equals VI, so I'm going to multiply V times I to get the power. 30 times 9 is 270. 30 times 6 is 180. 30 times 3 is 90. And again, my check, the power should add, and they do. So the next example, we have an ammeter reading 8 amps. So I1 equals 8, because that's the I going through this first resistor. And then find the resistance, voltage, and current for each part. So we'll make up our chart again. VIRP, total 1, 2. Okay, and our total voltage is 40. Our I1 is 8. And we have this resistance is 10 over here. Now this seems kind of complicated because they're all in different columns and different rows. How am I going to do it? But remember, the voltages are the same. So I know this voltage is 40 and this voltage is 40. Now it seems pretty easy. I can do V equals IR over here. So 40 equals something times 10. So this has to be 4. Then my next step, well, I can do a couple things. I'm going to do 40 divided by 8, and I'll get 5 here. Be careful with this R, though, because I can't just add them. I can do the 1 over rule, but I'm not going to do that just yet. What I might do next is add these I's, because in series the I's add. So 8 plus 4 equals 12. Now I can do 40 divided by 12 here. 40 divided by 12 is 3.3 repeating. And then finding the powers, I do P equals V times I. So 40 times 4 is 160. 40 times 8 is 320. And 40 times 12 is 480. Again, I check. Those do add, so that's good. I'm going to kind of draw something on here just so you see it. So the I total, I coming out of the battery, is 12. Okay, and this I, the I going into this one, is 4. And if you draw them on there, you actually see it. When it gets to this point, this 12 gets to here and splits. 8 of it goes one way, 4 of it goes the other.